Hello and welcome to the third and the last lecture in chapter 18, file input and output in Python. Here we are studying this thing. One, introduction to file handling, reading and writing text file, then working with CSV file, handling Excel file, JSON data handling. That was the last topic which we did in the previous chapter. And now we want to do this binary files and serialization. And then handling large data sets. Both these topics we will do in this single lecture. So let us start with first binary files and serialization. In the beginning of the chapter also, I said this thing, but again quickly revising it. That we are almost now at the end of several chapters which were discussing this part of our data science life cycle. Right now, when we will progress to this model creation, and we will use a suitable algorithm, may it be linear regression, logistic regression, random forest, XGBoost, SVM, KNN, neural network, or whatever model we use. But ultimately, that model is to be deployed on a cloud. So this model deployment, and it is to be deployed in a binary format. So you need to convert your model, final model, after appropriate validation that it gives proper accuracy, precision, recall, F1 score, or whatever parameter you have targeted, and it is giving the best. It is the best possible model out of all models which you have tried. Then you will do this conversion of the best model into binary. So how to convert that best model into binary? That process is called serialization. And once that model is deployed in the binary format, now whenever user gives some input, suppose this model is deployed on your website and it is a predictive model, say to predict the stock price of maybe Apple stock. Okay, now user is visiting your website today and he wants to invest in Apple stock. So he wants to first try the prediction model which you have developed, and for that he enters his purchase price, maybe then some time duration for which he can wait. Maybe he wants to invest for 6 months or maybe 5 years, depending upon his time horizon. Then he wants to predict what would be the future price using a time series model, right? So at that time, the binary model, which is a serialized model, that must be converted back to that is loaded in your web application's environment. That is the environment in which your web application is running, and it is converted back into the binary from binary it is converted back into the usable format. The user inputs all its data that my stock is Apple, or he may input more than one stock also if you have provided the user interface for directly simultaneously predicting the price of 5 stocks. Then he may enter Apple, Amazon, Google, Microsoft, and maybe Nvidia. So he will enter 5 stocks, and he will enter the horizon that 6 months. I want what will be the price. So before the prediction is made possible, when the model is loaded in the environment in which your web app is executing, then it is deserialized, or it is converted from binary back to usable format, correct? And then that model predicts the outcome, and if that outcome is displayed on the user interface. So everything inside that remains hidden from the user. User does not see that there is a model. He does not see that it is in serialized format. He does not see that it is getting deserialized and all that. But that is what we want to learn. Okay, so this is one example. Now, not only a machine learning model can be converted into binary format, but any data form, may it be a dictionary, may it be a list, may it be some user-defined data structure like a class and its object instantiated from class. So anything can be converted into binary format by using a library which is called pickle library, Pickle. There is another one also that is called joblib. Of course, you will have to install both these, either by pip install pickle or by pip install joblib. Okay, so both these will convert your model or whatever data structure you have, a dictionary or list or a class, object instantiated from class, whatever, it will convert it into pickle object, and it will save as a file. You can give any file name. So this is what we want to study. Okay, once it is saved in this format, then it cannot be opened by just double clicking or something. For example, here at present, let me check first that there is any data.pickle file present or not. So data.pkl. Okay, I think it is already there. If by previous iteration, when I took the lecture for my class, so I just delete that, and now there is no data.pickle file. And now I create a simple dictionary in which there are 3 columns. If I write this format, then it will look familiar to you that these are the column names: name, age, and occupation. And this is the data in that column. Only one row is there. Alice is under the name, age is 24, and occupation is data scientist. So this is my data. Now I just want to open data.pkl. Now I don't have any data.pkl here. So this we know that if you write wp, then that has capacity to create the file. So with open data.pkl, that line will automatically create a binary file. Okay, and Thereafter, pickle.dump. Again, here it is not dumps, but dump. When you want to write to a file, you have to provide two positional argument. What data you want to write and in which file name you want to write. Okay. So therefore, two positional argument cannot be handled by dumps command. Dumps is used when you want to display the output here. Okay. While dump is used to store some data in binary format in a file. Now again here also the file name is just simple data.pickle because I want to create that file in my this directory only, which is my this same directory as where I am executing my Jupyter notebook. But I can use C user is eq and whatever entire long format of the file name, that is fully qualified file name. Then the file will be stored in that folder. But here it will be displayed here. Currently there is no data.pickle. So let us execute this and you will see that immediately data.pickle will be created like this. Now if I try to, it is just 69 bytes because it is very small file. Okay, just one record is there. But think that there are millions of such records of employees or maybe some citizens of a particular city. Then you can write everything in one binary form. If I try to double click on that file, I will get this kind of error. File load error from data.pickle. This data.pickle is not UTF-8 encoded. And that is by purpose because, as I said, mostly here we are storing our data in this manner. But mostly it is used to save the model in the say best model.pickle format. So that model is developed by a skilled data scientist whom you are paying high salary, and that data scientist has put days or even weeks of effort from raw data to the model stage. That is that will take weeks of effort to reach. So you will not like your model to be exposed to others while it is traveling through the internet. But when you deploy your model on the cloud, then in between it will travel through the internet. So then this has that mechanism that binary file will not be, you will not be able to open just by double clicking it. I can even try by going to that folder basic DS and here I can find my data.pkl. So data.pkl. So here is my data.pkl, and here I can try to open maybe with open with I think that open with notepad option is not there, but okay, let us open with PyCharm. Try to open with PyCharm. Then PyCharm will take some time to load. Okay, I think in PyCharm, I think okay, edit with PyCharm community because that was professional version. So perhaps I think my license of professional version has expired. Okay, now in this community, I can get this kind of output. So something is at least visible there, that the name is Alice, age is something which is not visible. Okay, and occupation is data scientist. At least whatever was plain text that is visible, but age is not visible, number is not visible. Correct? So you can check here that that was the data, name is Alice, occupation is data scientist. So that much is visible, but that is because this is just simple dictionary. If you save your machine learning model as pickle file, then nothing will become clear. Okay, because it will be a large pickle file and complex pickle file. So it is by intention that kind of file is kept. Okay, now suppose I want to read that pickle file, then what I have to do? Then I can I will have to load the data. So when I say that it is not possible to read it, I am saying that it is not possible to read by human eyes, but it is possible to read by program. So what I do is again import pickle, and this time I open my file data.pickle in the read mode, read binary. So you can see the difference there. Here earlier we were always using R mode for reading and W mode for writing. Now here we have reused WB, write binary, and similarly now here I am using read binary as file. We load that file using pickle.load and save it somewhere, and then we print the data. So if I print, now I can see everything that it is a dictionary like this, and I can even do that pretty print and all that to get exact nice format. Okay, so this is how binary data can be written, and this is how, if there is already a binary file which is present in my working directory, then I can load and read that binary file. Okay, now let us think about this part, how to handle large data set. So for large data set, I have here one data set called around customers data set, which was very large. Its name itself is customer, and then 2 and then total 3 and 3 zeros. Okay, so that means customer 20 lakh.csv. That is the name of the data set. Now 20 lakh means 2 million. Okay, so 2 million customer records are there. Let us try to open that data set. Even if it is a CSV file, if it is of suitable length, then Excel can open. But here this file is very large, so let us try to open using Excel. 333 MB. So even Notepad perhaps will not be able to open. So a lot of delay will occur. So I'm pausing the recording and I will show you the result after some time. Okay, so this is the same Notepad and I have opened it after around maybe 5 minutes or so, but it is still not responding and it has actually hanged. So what I will do is I will now close it, close the program, reporting the problem to Microsoft. No need of reporting the problem because that is not an issue with Microsoft. Then I try to open with Excel. So open with Excel. And here it is showing CSV opening the 2 million customer files and 15%, then 22%, then 28%, then 35%, 42%, 49%, and it shows error. So that means that 49% of the data could be loaded. This data set is too large for the Excel grid. If you save it in this workbook, you will lose data that wasn't loaded. So 51% of the data would be lost. Of course, there are a way to split the file and all that, but that is a very tedious business to do. Okay, and if losing 51% of the data is a data scientist's nightmare. So clearly, I can press OK, and remaining 49% would be loaded here. But that is of no use to me because doing data analysis on 49% of the total data, that is roughly only 1 million rows out of 2 million rows. That is surely going to give incorrect model and error prone analysis. So I will close these also. Now what method is then left with me? So I have to import my file using Jupyter Notebook only. Okay. So let us use panda read underscore CSV to import my file using Jupyter Notebook. So I will use this simple script and it will be able to read that file and load it in the Jupyter Notebook. Okay. So for that, import pandas and decide some chunk size. Chunk size is equal to 1000 means when I use this pd.read underscore CSV, it will read not one row at a time, but directly a chunk of 1000 rows because my chunk size is 1000. That is why chunk of 1000 rows will be read and displayed here. Okay. Now compare that with this case where data was read using same read but not read underscore CSV of panda but CSV reader, and here the data was read in this manner, not this particular case but rather this with for loop, right? So here this for loop iterated on one row at a time because my data.csv was very small file. So if I open that just for your recollection, then data.csv was just a very small file like this. So it read one row at a time and each row was displayed in a list. So this was during the first iteration in the for loop, this was in the second iteration in the for loop, this was third iteration in the for loop, like that. Now there I could afford that because there are only 13 rows or 12 rows and fine. But here in my case there are 2 million rows are there. So if I just read using for loop row by row for row in customer hyphen 2 million dot CSV, then that way I will not be able to read. It will take a lot of time and mostly things will hang somewhere in between. So that's why I have decided a chunk size and I initialize some iterator object first. So my iterator object is initialized in this manner that whatever CSV file which you want to read, that file is called an iterable. So a CSV file is an iterable. That means a for loop can iterate through it using some iterator. So since it is a CSV file, I have to create a CSV iterator. Okay, and therefore I'm using read underscore CSV. If it would be Excel file, then I will create Excel iterator, and at that time I will use read underscore Excel or whatever that command was. Okay, and so then this iterator object has 2 parameters. One is the name of the iterable, and second is the chunk size. Now chunk size here, this 1000 I could have written directly also here, but normally such hard coding is not considered good. The reason is that tomorrow I may encounter even bigger file, so I may need to increase this chunk size to say 5000, or I may find some file which is only 1/4 in the size, so I may reduce this chunk size to 250. So that's why it is better to initialize that separately and put that value chunk underscore size variable is here. So that means in short, what I'm saying is I'm just putting 1000 here. Okay. So what this sentence reads is PD read this iterable, okay, and in a chunk size of 1000 rows. So 1000 rows, but next 1000 rows, next 1000 rows that way, and store the output in this iterator. Then don't use for loop for the entire file because that will give output row by row, one list at a time, second list at a time. I just now showed you. But instead of that, use for loop with chunk. So it will read now the file chunk by chunk. So first iteration will directly read a chunk of 1000 rows. Next iteration will read another chunk of 1000 rows. Next iteration will read another chunk of 1000 rows, and so on. Right? So for chunk in CSV underscore iterator, print chunk dot head. So let us print it, and you can see here that asterisk is seen. So that means the process is still going on even without going down. And here this also kernel state is busy. So that means that the process will go on. And here chunks after chunks after chunks will be added slowly, slowly, slowly. You can see more chunks are being added. If I quickly scroll, then you will still actually see chunks being added. Okay, so chunks are being added, and still that kernel state is busy only. This here where the virtual environment name is there at the upper right corner. Now kernel state has become idle. So that means now hopefully all chunks are read. And if I see this, then you will see that last chunk, it starts from 0, that we know. So the last chunk is 1,999,004, like that. Okay, so that is 000, sorry, this one. So that is the beginning of the last chunk, correct? So that shows how chunks can be read. And total how much time elapsed, that around 13 seconds elapsed. And remember, I did not print the entire chunk, I just printed chunk dot head. If you see the code again carefully, then for each chunk was of 1000 rows, but I printed only top 5 rows, chunk dot head. Now when you try this on your laptop, at that time you will perhaps not even be able to read head, because most of the laptops will not have sufficient memory. This is a very powerful system on which I am doing, 64 GB RAM and plus 2 GPUs and everything. So this could read. So if you cannot read, some error will be displayed. So I will show you what error will be displayed. But first, I am trying to print the chunk. Again, in my case, it was successful. It will print successfully. It will take even more time. Previous took 16 seconds. This again shows the kernel is busy, and here asterisk is shown. So let us see. Wait until the kernel becomes idle. So I am printing chunk, entire chunk, not just top 5 rows of the chunk, but entire chunk. Of course, that will print top 5 rows and bottom 5 rows. If I want entire chunk, all 1000 rows, then I should set that option pd.set underscore option and display.maximum underscore rows equals none. If you remember earlier we had seen that option. Still it is coming in next cell. So we will again see that option. But you have to use such option. Then you will be able to print all the chunks. But that would be even more difficult, because then here for each chunk, when you wrote chunk.head, only top 5 were printed. Now when I wrote chunk, then top 5 and bottom 5 for each chunk are printed. And you can see 16 seconds have already passed much earlier, and 10 seconds. Now after 10 seconds, yeah, it has. So that is because the earlier was already there in the memory, but it is taking a lot of time. And in your case, mostly you will encounter some error only, but all chunks are there. Okay. Now I will show you what error you will encounter and how to avoid that error. Assuming that you have sufficiently powerful hardware, still, even if you have very powerful hardware, still you will encounter that error, because by default Jupyter is configured that way that at a moment in 1 second it can allow only 1 MB data. So 1 MB per second, that much data is allowed. Now when we try to print this much file, then the file itself is so large, and it tries to print multiple MBs per second, and then Jupyter's input output buffer cannot print that. If I see the size of that file, customers, you can see that it is 333 MB. So Jupyter will try to print more than 1 MB per second, but its configuration environment variable is set at 1 MB per second at the most. So therefore, it cannot read it. So as I say, I am getting it because I have already modified my environment variable, but I cleared the output because I want to show you those things. First of all, if you want to print and all 1000 rows in your each chunk, then you have to set this option pd.set option display max underscore rows none. Then you will print each chunk, not only top 5 and bottom 5, but 1000 rows for first chunk, 1000 rows for second chunk, 1000 rows for third chunk. It would take very long time, and it might throw error. What kind of error you will see? You will see this kind of error, that IO pub data rate exceeded. The Jupyter server will temporarily stop sending output to the client in order to avoid crashing it, or your client may, that means this Jupyter notebook in your browser may simply crash also. So to change this limit, set the config variable --server app dot iopub underscore data underscore rate underscore limit. So change this variable. Current values are this much bytes per second. Now this many bytes per second. So if I remove three zeros from the end, that is 1000 kilobytes per second. Or if I remove three more zeros from the end, then it is 1 MB per second. So it's a very small rate for this 333 MB file. Okay, then therefore you will always encounter this error. I had changed my rate to this. So that means what I did, that was 1 MB per second. I added two more zeros. You can add as many zeros as you want, provided you have sufficiently powerful hardware. So I added two more zeros, means this was 1 MB per second. Now I am reading 100 MB per second, and as a result, that file can 333 MB file can be easily read. So I will show you how to change this environment variable, because it says that if you want to change the limit, set the config variable, this config variable, to this new limit. So this is my new limit. These are just a screenshot. Remember, now, this is not error which is triggered. These are just a screenshot. I first triggered the error and took the screenshot so that I can show you that this kind of error you will see. It is a markdown cell. It is not code cell. So no error has been triggered for my case. Okay. Now how to set this environment variable? For that I have given this method. Upper one is picture for Linux and lower one is picture for Windows. In both, only the first line is different. Open the command line or terminal and execute this command: Jupyter lab space lab hyphen generate hyphen config. Because when Jupyter lab is installed, by default it does not create any configuration file. So when you execute this command, same command is there, but here in Windows you will open the command prompt cmd and again Jupyter hyphen notebook. There Jupyter hyphen not hyphen space lab was there. Here Jupyter space notebook is there, and hyphen generate hyphen config. Okay, and that will generate a config file. This is where the config file will be on a Ubuntu Linux. So it will be in the home directory. There will be a hidden directory .jupyter, and this is where the config file will be on Windows. So it is in C users eq. In your case, instead of eq, that is the name of my analytics firm. Instead of that, your name or whatever name your PC is, that your PC name will come, and then .jupyter. Okay, so there such config file will be created. Now I show you that config file. So for that, C users eq and .jupyter, and you can see here that file is there. Okay, so if I double click on this or open with Notepad, then open with Notepad. So this is the file where that environmental variable can be found. So now read further on our Jupyter notebook. Okay, I have opened. Now what to do? So then find out this environmental variable. That is what this error says, that hyphen server app iopub data rate limit, that very environmental variable you want to find, and adjust its value. So I had originally value this 1 Mbps, from which I made it 100 Mbps. So here iopub I am finding, control F for find, and iopub. So that will give me that line. Okay, iopub is not found. Why? Okay, down. That's why. So downwards. Now here I can find that c.server app iopub data rate limit. Okay, and here I already increased it. That's why now it is this many bytes per second. But if you generate your config file and open by Notepad, you will get this. So I made it this, and that is I increased 100 times. So instead of 1 MB per second, now it is 100 MB per second. Okay, and then I closed it. After closing it, because save, I will say not don't save, but you will have to save it. In my case, it was already changed, modified, and saved. After closing that, what you have to do is you have to restart Jupyter. So that means wherever this Jupyter notebook code was executing this, I have to go to File and Shut Down. So it will ask me that do you want to shut down the kernel? You will have to say shut down. Here I have already done all the things, so I am just clicking cancel. And again start the Jupyter lab. Then the new configuration will take place. And thereafter you will see that this error will not occur. Okay, so then because now your rate iopub rate limit has changed from 1 Mbps to this 100 Mbps, correct? Okay, so this is how you can print the file. Now if let us try to do the same thing for another type of file, which is called paraquet file. Its spelling is Paraquet, pronunciation is paraquet file. Paraquet file is a large data file, and it is very widely used format for so yeah, this is the name. Okay, so let me try to first find it. Yeah, yellow trip data. It is here 47.6 MB. Okay, but its problem is different. Even if you use the chunks, then also most of the time Jupyter notebook will not be able to open it, and perhaps you might have to increase your this limit to even more. Okay, so I have not run this set option, or maybe I just ran it, but if you run this, then it will show all the rows instead of head, and then it will throw the error. So my code is this actually, print df.head, but instead of that, if I write print df, then it will throw error. df.head will not throw error. Now what to do? How to get such paraquet file? So I have given one this link, hyperlink, that go to this hyperlink, and New York taxi data here. This is that hyperlink, and this is the taxi trip data record, and this is the January 2024 record, yellow taxi record, green taxi record, etc. So take any one, and it will say that you are leaving the New York taxi's website, and the paraquet file will start downloading. Okay, I am cancelling because I have already downloaded and placed it here. Okay, now this option ideally should not be run because otherwise the file will become very large. But if it is there, then you should use print df.head. File will become very large means the display file in the Jupyter notebook will become very large. Okay. Now otherwise the reading the paraquet file is also very simple. Okay. That you have to first install some this pip install py arrow. Okay. So pip install py arrow will be required, and if you do this, I have already done it, but if you do this, it will take few seconds before this new library. It is just like Panda or NumPy is a library where for paraquet file you will have to download this library and install in your virtual environment basic ds underscore py 311. Okay, I am not setting this option at present. Thereafter, it is very simple. Import pandas pd.read underscore paraquet. So just like it is read underscore csv, read underscore tsv, read underscore I think there was another format also, maybe Excel, but similarly it is now read underscore paraquet, and just write the name of your paraquet file. Here my file is in same directory as the script is executing, so only the name is sufficient. Otherwise I have to write full location, C user, C cube, document, or downloads, wherever my file has been downloaded, right? And then print. I have at present commented out this. I'm just printing the head. Okay. You can see here it is so busy, but now the head of my paraquet file is visible. Now this is the greatness of this pandas, that paraquet file is not it is not possible to view that file by any other method. For example, if I go to that basic DS and I find yellow taxi, this paraquet file, right? If I try to open with, say open with, there is open with is not there. So maybe share with PyCharm, edit with PyCharm community, right? So if I, because PyCharm community, if you remember for the JSON file, at least showed me something. But for paraquet file now you see what it shows. This is what it shows. Can you make a head and tail out of it? Then no. It can open, but nothing is readable by human eyes. But that is the greatness of Panda, that it could load the file here. Okay. And instead of print df.head, I can write print df. Okay. So in that case, it will take a time, but entire data frame has 2964624 rows and 19 columns. Okay, and it is coming out to be this. It is because I did not set that option. Therefore, even when I use print df, it just printed top 5 and bottom 5 rows. This dot 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 means in between rows were skipped. Now, if I set that option and try to print entire data frame, then you see what happens. Here, kernel is busy, and it will remain busy for multiple seconds, and still, in spite of that, I have modified that IO put buffer and all that. I made from 1 MB per second to 100 MB per second in my environment Jupyter config variable. Mostly this will throw error. So I'm pausing it because it will take 100 seconds or 200 seconds. So I cannot keep video hanging. But whenever it will throw the error or show the output, I will start recording. Okay, so here you can see I allowed it to execute for 539 seconds. And in spite of that, when I tried to print entire paraquet file, I got that error even after increasing the limit to 100 MB. Okay, this was the pasted or markdown cell in which I had pasted the error message just so that you can know. But this is the actual error which is triggered by my code. So that is the reason why we don't print df, but rather we just print df.head. Okay, so now I again execute it, and within maybe what has happened? Unterminated. Oh yes, here this. Okay, so again execute it, and it will quickly execute because it has, the previous result is still in its memory. So df.head is fine, right? Now, if you want everything, then you can first set this option and then you try, but you will not be able to do. So here I have written what will happen if you try to do that. So if we try to print entire paraquet file, that is 49 MB file, around 49 MB file, by print df, that is this, then you will not be able to print it. So that is why we did it by print df.head. Okay. So here also we will keep it print df.head only. Okay. So that means in this. Okay, I have already commented out that, and print df.head is this. Okay, fine. So this is what is the situation that you got the error which I have pasted as a example for your reference, that this kind of error will be triggered. And even after increasing my limit 100 times, I still got that error. So there is I can have more limit, still I can add 2 more zeros or 5 more zeros because I have sufficiently powerful hardware. But otherwise, in most of the case with common laptop or common desktop, you will see that it is not possible to print this kind of paraquet file directly in a Jupyter notebook. You can print head, but you cannot print the uh, the entire DF. Okay, so that is something which is important to note. Okay, now this is I think why. Okay, this is also marked down. That is why. So if you try this, I wanted to show that if you try these, then this error will be triggered. Okay, so if we try entire paraquet file by using print DF, then it may take a lot of time. I showed 357 seconds and still it triggered error. So we adopt this kind of technique. Then how to print this file? Then just like in case of that large CSV file, what we did was that 2 million records CSV file, that this one. Okay, we divided into chunks and we use for loop not to iterate over each row, but rather iterate over each chunk of 1000 rows. So exactly same thing we are trying to do for the paraquet file. So import pyarrow.paraquet as pq. Then beside the path, here this is itself the fully qualified path because the file is in the same folder or directory as my Jupyter, this script which is executing. Then this n is equal to 200. Now what is that n? That will come later on. You can adjust this value according to your different requirement. First open the paraquet file. So paraquet file equals, here you can write anything, x, y, anything. This is just the name of a variable, equals pq dot paraquet file path. So that means I'm using this here. As I said, I could have directly written this, directly copied and pasted this here only, this way, but that would not work. Okay, so instead of that, that will work, but that is not how it is done. Hard coding is not done. Instead of that, file path is kept separate, so that even if a long file path is there, C, users, ecube, documents or downloads, and then inside this, then also the code remains legible and decent in appearance. Okay, now define the number of rows per chunk. So chunk size is 1000. So that means this n is not chunk size. Okay, then what is that n? That will become clear just now. Okay, now iterate over batches using iterator. So for I in range 0 to paraquet file dot num row groups. Now what is the meaning? 0 means the very first row of the whole paraquet file, and this paraquet file dot num row groups, this dot num row groups gives the total number of rows. So that means if total there are 1000 rows, then this would mean this much will mean 1000. If there are total 10,000 rows, then this much would mean 10,000, like that. Now here I don't know how many rows are there, because in previous case I had indirectly given in that case that there are 20,000 2 million rows in this CSV file, but here I don't know. So if you don't know, then paraquet has this attribute that you just write dot paraquet file name and then write dot and num underscore row underscore groups. So that will give me the total number of rows. So in short, iterate from 0 to this row groups. In what batch size? Then in chunk size. So that means in size of 1000 here. Okay, and end row is equal to minimum of I plus chunk size. So I varies from 0 to end of the paraquet file, last row, first row to last row, and end row, here first we decide as the minimum of I plus chunk size or paraquet file dot num row groups. The reason is that if I plus chunk size increases, because see, you are doing chunk in a chunk of 1000. Now suppose finally after all iterations are done, only one iteration is left and only 300 rows are left. So at that time, if you don't provide these, end row is equal to, and you just say that end row is equal to paraquet file dot num row groups, but that means the next iteration will directly jump by 1000 rows, but now only 300 rows are left. So what you do is find a minimum between these two, I plus chunk size, that is current value of I plus chunk size, okay, and paraquet file num row groups. So here this paraquet file num row groups will be only 300 because now only 300 rows are left after many iterations. So then the end row would become 300. But for other iterations, previous iteration, this I plus chunk size, that would be the num row. So end row. So that means first row is 0, then next row will be 0 plus chunk size. So next row will directly go to 1000. Then next row will be 1000 plus chunk size, because I have become 1000. So now it will be 1000 plus chunk size, correct? So then that would be 2000 and so on. So this is important step and you should understand. Then convert your paraquet file into a table. So table is equal to, again this is just the name of a variable. Okay, so paraquet file dot read row groups, just like this is an attribute num row groups. Similarly, this is an attribute read row groups, and read which row groups? In the range I to end row. So So I to n row means first I is equal to 0, and at that time n row will be 0 plus chunk size, so 1000. So that means read 0 to 1000. Okay. Then read next time I will be equal to 1000, and this would be 1000 plus 1000. So read 1000 to 2000. Okay. Next this would be I would be 2000. Then read 2000 to one more, that is 3000, like that. Okay. So that is how you can write this range. Okay. And then convert the table to pandas data frame. So pandas data frame, and this way iterations will continue, and more chunks will be added to this table until what? Until paraquet file.num grows. That means until the end of paraquet file. Okay. So then you go on doing that way and create a table. So what I can do is I can take these many lines in the next cell, and I can just show you what that table would be. Okay. Of course, paraquet is there, so maybe whether it is printed in the Jupyter or not, that would be an issue. But let us try. So yes, it is printed, but this kind of thing is printed. That is, its attribute is printed. Py_arrow.table vendor ID. Its all columns are printed. That these many columns are there. First index column is vendor ID. T prep pickup that time. Remember, it was taxi data. So pickup, then T prep drop off dash time, passengers count, how many passengers sat in the trip, that taxi trip distance, how many kilometers it went, rate code ID, maybe that was some taxi fare was decided according to some code, then store and forward and all these things, location and payment type, whether the payment was done cash or some credit card or digital payment, what way, fare amount was how much, extra, that is some extra was charge was taken from the passenger, maybe night time extra charge is there, or maybe some passenger asked to wait for some time, as a result of that some extra charge was taken, what tip was given, and all those things. If there were some toll booths in between, then tolls were paid, and then this shows some sample rows. Okay, so this is that table, but again you can see it is not still pandas data from. So what you have to do is, now I am removing that table and I am putting the code back to where it was. In last step, I have to put my table to be converted into pandas data frame. So table dot to_pandas. Now this command has been used, I think, for the first time in entire course. Okay, many commands here are being used for the first time. Read underscore, so file.num underscore row groups, read underscore row underscore group, because this is fine that these are used for the first time, because paraquet file itself we are handling for the first time. But pandas we have been using from I think third chapter or fourth chapter, but this was not used anywhere. So if you have a table and table object py_arrow table, and if you want to convert it into pandas data frame, then you can write to_pandas and then process each data frame chunk. So that means at that time you can use this value. So chunk size was already used in this for loop, but where this n is used, so you print df.head and 200 rows. Okay, now instead of that someone says no, I want to see 500 rows, then he will write df.head 500. Okay, someone says that, oh, I want to see all 1000 rows, that is entire chunk, then he will write here df.head 1000. So this is stored separately. I can hard code also here. In fact, if I just write df.head, then it will print by default first 5 rows, that we know. But I want it to be modifiable, so I stored that n in a separate variable. So n is not the chunk size, but n is the number of rows from each chunk that you want to print. Is that clear? Okay. Now, first I am keeping n is equal to 200 only, but still 200 rows I think will not be visible, top 5 and bottom 5 only. No, I have set that option. pd.set option, this was executed, display max rows none. So all 200 rows are visible. Okay, 0 to 199, and multiple columns are there. All columns could not be fitted in one horizontal width of the Jupyter window. As a result, this backslash whenever comes, that means the same data frame continues over after 200 rows. This is the same, again starts from 0, and the remaining column are here. Still same data frame continues after 200 rows, and this remaining column are here. Still same data frame continues, and after 200 rows, now there is no backslash, so here my data frame is over. Try to imagine, that means these all are beside on the right side of the very first, but since there is no sufficient space on the screen, that is the reason why they are printed like this. Okay, now these are 200 rows. Suppose someone says no, I want to print entire chunk, so he will have to write 1000 rows because his chunk size is 1000. So then in that case it will be printed in this manner, and first 1000 rows, few columns, then here, then next 1000 rows, another few columns, then next 1000 rows, another few columns, like that. Okay, so this is how you can get the various chunks. Fine. Okay, so this is the ideal way of reading paraquet file. Just like a large CSV file also we read in different chunks. Similarly, a large paraquet file also should be read and displayed in chunk. Okay, then you can take the next chunk and next chunk and next chunk. That way you can display other rows. Okay, so here I am clearing this output, and maybe like this. Now here, okay, This was that how to change the configuration of the Jupyter notebook that I have already shown. So I think it is over. Chapter is over here. Okay, and these are the three exercise questions. Exercise 18.1, and in which there are three questions. So you can try this at your home. So this also became a long chapter, almost 1 hour. So thank you for that. But that is because we had to wait for a long time for output to be generated, because both data frames were very big in size.